When we're drawing the sine curve, we need to know where the values for sine came from. They actually come from the unit circle. If we cast our minds back, the unit circle consists of a circle drawn within the axes of 1, minus 1, and over here we've got 1, minus 1, and this is our 45-degree angle, which is pi over 4, pi over 2, 3 pi over 4. Now what we do is we consider that the sine of an angle, say the sine of pi over 4, is the projection onto the y-axis. So that's the y-axis, this is the x-axis. So the projection would be this length here. So if we label our axes amplitude 1 to minus 1, here we would have pi over 2, here we would have, that would be 0, this would be 3 pi over 4, this would be pi, this would be pi over, no, this would be 2 pi. If we bring this projection over to this side, at pi over 4, which would be over here, it would sit like that on the axis. At pi over 2, the projection would be to 1, so it would go up here, so that would be our projection onto the y-axis. Here at 3 pi over 4, the projection would be there, and at pi it would be 0. And when we join the dots, we get our sine curve for quadrants 1 and 2, and then following that round for quadrant 3, and then up for quadrant 4 to 2 pi. When we are drawing a sine curve or a cos curve, we need to label 5 things. The first thing is the amplitude, which is 1, minus 1. The second thing is the period, which is here, which is 2 pi. Third thing, half the period, which is here, which half of 2 pi is pi. Then half the period, which is here, which is pi over 2. And then we add this, and we get 3/4 of the period, which is 3 pi over 2. So those are the 5 things we need to label. 1, 2, 3, 4, 5. When we talk about tan x and the unit circle, tan x is represented by this line, and tan x has real values from minus pi over 2 to pi over 2. So when we're drawing our tan x curve, if we do our x and y, we have we have pi over 2 on this side and minus pi over 2 on this side. Our tan starts here in quadrant 1 as 0 and goes up like this, and then in this quadrant it goes down like this. It never actually reaches pi over 2, so pi over 2 and minus pi over 2, which is over here, vertical asymptotes. If we want to draw from 0 to 2 pi, what we do is first we draw in the vertical asymptote, so this would be an asymptote at pi over 2, then an asymptote at 3 pi over 2, and then an asymptote at 5 pi over 2. When we're asked to sketch a sine curve or a cos curve, we're usually given something in this format, where A is the amplitude, the period is given by the normal period, say it's 2 pi for sine, and we divide that by B. The phase shift is given by minus C over B, and the vertical shift is given by K. Y equals 3 sine x, well, this is the argument. The amplitude we can see is 3. The period is 2 pi over B, and B is just 1, so it's 1x, so it's 2 pi over 1, which is just 2 pi, so that's the period. The vertical shift, there is none, there's no plus k here. And phase shift, again, there's no plus in this argument, no plus c, so phase shift is 0. So drawing this, let's draw our axes. Put in our amplitude. So our amplitude is 3 minus 3. Our period is going to be a normal period of 2 pi. So our sine would go up, down, and there, like that. Then we need to label our half the period, which is pi, half a pi, which is pi over 2, and then 3/4 of pi, which is 3 pi over 2. Okay, we're asked to draw y equals sine x plus pi over 4. So our amplitude is 1. Our period, there's no value or thing before the x, so our period is still 2 pi. Our phase shift is minus c over b, which is minus pi over 4, and b is 1, so it remains minus b, and there's no vertical shift. There's no plus k. So let's draw this. Let's just draw a normal sine curve first. So a normal sine curve would go around like that. This would be 2 pi, and this would be pi, this would be pi over 2, this would be 3 pi over 2. And what's happened here, we want to make a shift of pi over 4 in this direction, so it's minus pi over 4. So we shift points, we choose points and we shift them pi over 4. So this would then, let's use a red pen, so this would then become minus pi over 4. This one would move over to here. The pi over 2 would move over to here. This pi would move over to here. This would move over to here. So our curve would then go up, around, down, and up like that. 2 cos 4x as our argument. So our amplitude is 2. Our period is 2 pi divided by the 4. Which is pi over 2. Vertical shift, there's no plus k, so that's 0. And phase shift, there's no plus c, so that again is 0. So let's draw this. So our period would be 2, let's draw that in, 2 minus 2. I mean our amplitude would be 2. It's a cosine curve, like so. Our period is pi over 2. Half of pi over 2 would be pi over 4. Half of pi over 4 would be pi over 2. And here we have 3 pi over 8. And that would be our curve. Okay, we're asked to graph y equals minus cos 2x plus pi over 2. So first we look at this. This means that there's a flip involved, the minus. Then we look at our amplitude. For the cos there's nothing, so that's the amplitude is 1, remains as 1. Our period is 2 pi over 2, which is a normal period over the 2, and this is just pi. Our phase shift is minus pi over 2, so it's minus pi over 2 divided by 2, which is minus pi over 4. And our vertical shift, there is none. So first of all, let's draw in our amplitude. Amplitude is 1 minus 1. Now our flipped cosine curve looks something like, goes around and back up here. Our period is pi. Half a pi is there, pi of 2, and then we have a quarter pi over here. So that's our normal cosine curve. Our flipped curve will start at -1, go up here, down here, and across there like that. And over here we'll have 3 over 4 pi. So this is our flipped curve, this is our normal curve. Now we need to do a phase shift. So this is the last thing we do, phase shift of -1/4 pi. So let's draw our axis again. So we've got 1, -1. Let's choose some points on our flipped curve that we're going to move across. Here we've got half pi, bring that down, pi, bring that down, 3 over 4 pi, 3 pi over 4, pi, pi over 2, quarter pi. So we're going to shift everything in this direction. So this point will move 1/4 pi that way. This quarter point will move that way. This half point, which is up here, will move up to the quarter point. This point will move to the pi over 2. And this point, which is 3, will move over here. So it's going to look something like through there, over there, through the pi over 2, and down like that. Graph y equals minus cos 2x plus pi. First of all, we notice there's a flip involved. The amplitude is 1. Period relies on this 2, so its period is the normal period, which is 2 pi over 2, which is pi. The phase shift is minus pi over 2, and then the vertical shift, there's no plus k, so that's 0. So let's draw this. First of all, our amplitude is 1, minus 1. When we draw a flipped cosine, it looks something like this, goes up to 0 and down and stops there. Amplitude is, our period is pi. Half a pi would be the maximum here, which is pi over 2. This would be pi over 4, and then this would be 3/4 pi. So that's 4 and 4 over there. So yeah. Okay, so that's our flipped cosine. Now we want to shift that way, so it's minus pi over 2. So what do we do here? We want to shift all these points, so that's this point here, this point here, this point here, this point here, that way, by minus pi pi over 2. So let's draw our graph again on a similar axis. So if this were pi, this was pi over 2, this was pi over 4. Similarly on this side we've got minus pi over 4 and minus pi over 2. So this minus pi over 4 is shifted over here to minus pi over 4. This minus 1 is shifted over here to minus pi over 2. So our curve goes something like this. Pi over 2 shifted here becomes up to here. And we go 3 pi over 4 shifted pi over 2. So that was 3 pi over 4. Shifted pi over 2, we get 3 pi over 4 minus pi over 2. So that's a 4, 2. So this becomes 3 minus 2, which is 3 minus 2, which is 1, which is pi over 4. So it goes over here. So 3 pi over 4 goes over here. So down and across like that.